So, how are you all? I hope you all are fine and doing well. I'm your favorite physistic and YouTuber. My name is Sayyida Fatma Rizvi, and I bring for you people the very interesting and informative videos of physics. And we are today going to start with the new topic, the subtopic of the electrostatics, which is electric potential. What is potential? Potential is the energy. We use the term potential in our daily life, like, has this person the potential to do something? Has this thing the potential to cross the boundary or stuff like that? Potential means energy, how much energy the person possesses. Similarly, like that of the human potential, like that of the thing's potential, charges also have the potential. So we are going to study in detail about the electric potential. All right, so let's start. First of all, we will discuss about what is electric potential, the amount of work done in bringing the unit positive charge from infinity to the certain point. It means that if the charge is at the certain corresponding place and we have to bring the charge, so in order to bring the charge, the amount of work is done on that charge to bring that charge from infinity is a certain place, to a certain point. So the amount of work done in bringing the unit positive charge from infinity to the certain point is known as electric potential. So for that purpose, let us consider the positive charge q, bring it close to another charge. Let us consider the point charge q, bring it to another charge from infinity to a certain point, so that the point charge will feel the electric field of the other charge. Let us suppose that we have a positive charge, okay, and a positive charge is generating the electric field. So and the other point charge is at the certain point, at the infinity point, and we have to bring it close to the positive charge. So in order to bring it close to the positive charge, we have to do the work on the point charge to bring it from infinity to the certain point, so that the point charge will feel the electric field of the positive charge, as it is mentioned, so that the point charge will feel the electric field of the other charge. So V is equal to W divided by Q. Electric potential is given by V, and it is equal to the amount of work done in bringing a unit charge from infinity to a certain point. Okay, so it is given by the formula V is equal to W divided by Q. Okay, so Q is a scalar quantity. Okay, work is also a scalar quantity. How work is a scalar quantity? So the question arises here, how work is a scalar quantity? Work is the dot product of force and displacement, and we have stated that force is the vector quantity and displacement is the vector quantity. So the dot product of two vector quantities are the scalar quantities. So work is also a scalar quantity. Work is a scalar quantity, charge is a scalar quantity. So potential, electric potential is also a scalar quantity, because no direction is needed in this specific case. Alright, so let us discuss about the unit of electric potential. Unit of electric potential is given by V is equal to J divided by C. Now what is J? Work is represented by joules, charge is represented by coulomb. So V is equal to and voltage is represented by volt. Okay, electric potential represented by volt. So V is equal to J divided by C. Electric potential is a scalar quantity, corrected, sorry. So we have discussed about the potential. Okay, then we have to discuss about the potential difference, like the gravitational difference, like temperature difference. There also lies a potential difference, that how much potential difference is created when the charge shift from one point to another point. Like there is a temperature difference. We if we want to get the accurate temperature difference, for example, the temperature is 15 degree centigrade, it's the higher temperature range, and the lower temperature range is 10 degree centigrade. So the exact temperature difference lies is 5 degree centigrade. So in order to measure the potential difference, let us consider the charge q placed between the two terminals of the battery. One is the positive terminal and the other is the negative terminal. Okay, so we take the two terminals of the battery. One is the positive terminal of the battery and the other is the negative terminal. We place the test charge between these two terminals. Okay, and the electric field is generated when the battery is connected with these two when the battery is switched on. So the electric field is generated between these two terminals. Okay, and the test charge is placed in between these two terminals. So what will happen? Amount of work done in bringing the test charge from one place to another is given by V is equal to W divided by Q. Okay, so we have the expression that V is equal to W divided by Q. So in order to find out the work done, we multiply V and Q, so we get the work done. Alright, so the amount of work done in bringing a test charge from positive terminal to negative terminal is given by potential difference is equal to work done VAQ minus VBQ, because the work is done in bringing a unit test charge from higher terminal to lower terminal, right? So amount of work done in bringing a unit test charge from higher point to lower point is given by VAQ minus VBQ. So we take the potential difference as VA minus VB. Q we take as common because the one charge is discussed over here. So children, just remember the one thing, that work is always done from a higher point to the lower point. Like if the person is at the stairs and want to climb the stairs, so he will run up quickly. Okay, he will do the work quickly from higher stairs to lower stair. But if the person want to jump from lower stair to the higher stair, so the extra amount of work is done. Similarly, if the person want to go to the Murray Hills, so it requires a lot of energy, a lot of potential to go and to climb to the Murray Hills. So similar is the case with the charge. As the work is done, the work is always done from a higher point to the lower point. So the charge will go from the higher point, which is the positive terminal, to the lower point, which is the negative terminal. So the charge will the work is done from the higher terminal. The charge will climb from the higher terminal of the battery towards the lower terminal. A higher terminal is the positive terminal and the lower terminal is the negative terminal. So the higher terminal is given by VA and the lower terminal is given by VB, or we can say the positive terminal is given by VA and the negative terminal is given by VB. So we get VA minus VB multiplied by Q, as the charge Q is the same charge. One charge is, we are dealing with one charge. So VA minus VBQ, we get the potential difference like that. Okay, similarly, if we want to if we want that the charge will jump from lower potential towards the higher potential, the extra amount of work is done. All right. So potential difference. What is potential difference? Potential difference is the amount of energy that the charge carries have between 2 points in the circuit. Okay, so the potential difference is the amount of energy that the charge carries between the 2 points in the circuit, right? So this is all about the electric potential and the potential difference. I hope that you people enjoyed the video. Keep liking, sharing and subscribing to my channel and spread the physics video worldwide. Okay, because this is a very interesting, entertaining videos, and I bring most informative videos for you people. So it's your duty to share, like and subscribe to my channel and bring my channel towards worldwide. Okay, thank you so much. Allah Hafiz.